Hello everyone, today we are talking about independent samples t-test. This test is used when we have two groups or two samples and we want to check the means for the two groups. So we use t-test to compare the means of two groups. A t-test looks at the two distributions and determines whether or not their means are significantly different, so it focuses on the means. Okay, let's this is the previous example that we had. So we have the first class and the second class. We are checking if there's differences between the mean of this class and the mean of this class. In the first part, that when we do the comparing means, the means part, we also compare the two groups, but we compare them without checking if there's differences or not between them. The software didn't show us if there's a differences. It only shows us the mean for the first class and the mean for the second class. And we could able to choose the standard deviation, the minimum for each class, the maximum value for each maximum score for each class, but it didn't show us if there's differences or not. So if this is as we learned before, if the significant value is less than 0.05, it means the classes are the two classes means are different, statistically different. There's a significant difference between the two classes. Alright, so but there's one thing we have to think about. Let's see this example and see what is the other thing that we have to consider. Let's say we have this country, the first country and the second country, and we need to check the means, if there are any differences in the means for the temperature, like for the same days. So we have taken 5 days temperature, like in specific time, let's say 12 o'clock, or let's say 12 like at night, so it's reasonable because there's no sun shine. So this is the first sample and the second sample. As we see here, that the test show us that there's no differences. If we just look at the values, so we can see that there is no differences. And if we calculate them, if we check the mean here, it is like around 10, and the mean here is around also 10. So 10 equal 10. No problem with this, and it will show us that there is no significant result, significant difference between them. Let's see the next country. If we had a next country, see this country, this is a third country. If we see the temperature here, it's 35 minus 15, 10 minus 30, 50. If we take the average here, it will show us 10 also. The mean here is 10, the mean here is 10. Okay, so what can we think about this? Maybe you don't feel good if you say that two means are equal, because the dispersion of these values is so bigger, like from 10 it's so big, and here's so little dispersion, so it's not very good to say that. Therefore, this independent samples t-test not only check the means, not only calculate the means and do this. No, it also check for the variances between the two samples. So it also check for the variances. Therefore it give us the result for the variance and for the sample. So if we see the hypothesis here, the null hypothesis say that the population variances are equal. So there's no differences between the two variances. Here we can find that this test can give us the variances are equal. So this we can say we can take H0, and this one we can say it can give us H1. The alternative hypothesis, the population variances are not equal, they are different. So the test for that is called the Levene test. If the significant value is less than 0.05, so they are different. Let's take this a little bit like this is a real example, not like a school one. An analyst at the department store wants to evaluate a recent credit card promotion. So we have two methods of, or two ways of promotion. To this end, 500 card holders were randomly selected. Half received a promoting a reduced interest rate on purchases made over the next 3 months, and half received the standard seasonal ad. So as we understand, this is the analysis. We want to check if there's any differences between this promotion, the new promotion that he reduced the interest rate for the customers to see if they are spending more. And this is the first group with they have the standard promotion that they get every year or every season. So we have the total number of customers are 500, 250 and 250. These are the new promotions. Okay, let's do the test using the credit promo SIV data file. So this is a app. Okay, we have the credit promo. We open this file. Alright, this is we can see this, for example, let's read this first record. The ID is, the number of customer is this one. The standard, he received the standard promotion, that is seasonal promotion, and this is his amount of spending. And this is a new promotion, this is amount of spending. This one, these two have see this is 2,300, this is 1,200. So here we have the type of promotion that has been used. Okay, we go to analyze, we compare means, and then independent samples t-test. Here's the test variable or variables. So we are testing the spending during the promotion. So we take this one here, and what is the classifications, or what is the grouping variable? It is the not the customer ID, the type of the mail, this is the insert the type of promotion. We define the groups. This is the group 1, we give it like 0 value, and the group 2 we give it 1, value. It is previously set that it is 1 and 0. Like if we go here to the variable view, variables, when we define the variable, when it was defined there, we check the values here. This is the values. It is 0 for standard and 1 for new promotion. Yes, it's previously defined, and we can see it from here. If we press the value labels, it switch between the values labels and the values. See, this is 1 0. So by defining, we write 0. The first group is 0, the second group is 1. Press OK. Here's the first table, group statistics. It shows that how many customer in each group who received the promotion, standard promotion and new promotion, 250 for each. This is the mean. This is the statistics for each group. This is an independent. This is the new table that we had. First, we check for the Levine test of for equity of variance. As we said before, if it is 0, it means they are different. If now it's far from 0.05, so they are, we can say that the variances are equal. So it matches the first, if you remember the cities and temperature, the first two countries which they have the same variance. So similarly, the variance are equal, is assumed. The equal variance is assumed. After we read this one, we go to the check for the equity of means, comparing the means. Now we can see here if the means are equal or not, or differences between the mean. This is a significant value for the two-tailed test. It shows that 0.02. This is less than the 0.05, and it means that it means that we are taking the alternative hypothesis that the two means are different. So there is significantly difference between the two groups. So what can we conclude by that? Now we will say it, but just let me. So this is a t-value, the degree of freedom. This is the lower and upper confidence interval part. This is standard error of differences. So our conclusion that there is differences. So the analysis is taking consideration of the new promotion that is taking effect for the customers. So we can conclude that since the significance value of the test is less than 0.05, we can safely conclude that average $71.11 more spent by the cash holders receiving the reduced interest rate is not due to chance alone. The store will now consider the extending offer to all credits customers. Thank you for watching. See you in the next class.